Hey guys, welcome back. Let's finish the study guide. Look at this. This question, number 18, says, what are rational numbers? So rational numbers are the numbers that we've been talking about the last few weeks, okay? The first month of school, we talked about integers, which are those positive and negative whole numbers, plus 0. Rational numbers are all those numbers that we mentioned, plus any fractions or decimals. So it includes kind of everything, all right? Let's get a definition in there, though. What are rational numbers? A rational number is any integer as well as any decimal, as any repeating or terminating decimal, and kind of abbreviate just for space, and any fraction that doesn't, have a denominator of 0. Remember, if there's a denominator of 0, it's undefined. Okay? So some examples would be, let's see, 2, 0, negative 4.8, 3.9 repeating, 1/2, negative 4/5, any of those. Those are rational numbers. Non-examples, however, would be things like pi, which is 3.14. That's what our abbreviation. Pi actually goes on forever. It never ends. Pi is an irrational number because it never ends. All right, so pi, or something like negative 7 over 0, because we can't have a denominator of 0 because that doesn't work. Or just any other decimal that happens to go on forever, 4.283. If it never ended, then that would be an irrational number, and we're looking for rational numbers. All right. Let's look at the next section, number 19. Complete the chart with the missing decimals, fractions, and percents. So looking at this, we did talk about it as a group of math teachers. We're going to move percentages to one of our next units. So this is not going to be on the test, but it's actually really easy to convert from decimals into percentages. So we are still going to talk about it just kind of briefly, just so you'll be ready for the next section of this. Looking at this, negative 1/2, that's a fraction. Now, this is one of those benchmark fractions you kind of learn when you're in elementary school. And you kind of learn fractions and decimals, a couple that go hand in hand just because they come up so often. So negative 1/2 is actually the same decimal as negative 0.5. Now, a couple of things. What if you didn't know that off the top of your head? And that's okay. Sometimes you forget these things. Negative 1/2, just like we talked about before, any denominator I have, if I can turn it into a place value that I know, meaning I can turn it into the tenths place or the hundredths place or the thousandths place, I want to turn it into that. I could turn this 2 into a 10 by multiplying it by 5. I'll do the same up here on the top. Then I get negative 1 times 5 is negative 5. So now this is out of 10. It's in the tenths place. So I know I want my decimal to go all the way to the tenths place. And then what number goes in the blank? It's the number in the numerator. I put this 5 up here. It's an arrow, kind of a poorly drawn arrow. Doing my best. And then I got this 0 out in front, and I put the negative with the 0. Okay, it goes out in front of the decimal. So negative 0.5 is what I end up with there. The percentages, whenever we deal with percentages, all I do is move the decimal place 2 times to the right. Watch. 1, 2. Any blank spaces get a 0, and now this percentage is negative 50%. All right? Let's look at this one. Decimal into a percent. All I do is move the decimal twice. 1, 2. Now it's 75%. All right? Let's look at another one about decimals and percentages. What about this one? All I do is move the decimal to the right 2 places. 1, 2. Empty spaces get a 0. This is now 170%. All right? Notice how that decimal had a whole number out in front. So it makes sense that it's more than 100%, 170%. Let's Let's look at this one over here. Oh, let me give some of this an erase just so I have plenty of room to write. Now, over here, we had 75. Let me give one more erase just so we can see really clearly. So I have 0.75. I'm trying to turn this into a fraction. Whenever I turn decimals into fractions, I look and see how many place values the decimal has. It goes all the way out to the hundredths place. So I want a denominator of 100. And then whatever number is after the decimal, we got 70. We got 75 after the decimal. That's what goes in the numerator, 75 out of 100. And I can simplify this by dividing both of these by 25. That's the greatest common factor here. And I get 3/4. That's the decimal we're looking for. Remember, if you can simplify, you need to. Looking over here, negative 0.8. Well, I'm just going to turn this decimal into a fraction, I'm going to look and see what place value the decimal goes to. It goes all the way out to the tenths place. I want 10 as my denominator because it goes to the tenths place. And then I put whatever's after the decimal. In this case, it's an 8. I put it in the numerator. And again, if you can simplify, you need to. These are both whole numbers. I can divide them both by 2. And I get 4/5. Negative 4/5. I forgot that negative almost. See how easy it is to do? Let's look at this one. 3/5. And there's a missing decimal. It says 60%. So, a couple ways to do this. I could multiply this by 2. So I turn this into a 10, which is a place value. 6 right here, 6 out of 10. I know that whenever I have my place value of 10, that's the first number after the decimal. And I go and fill it in with the number in the numerator. Or if you don't want to do that, I could look at this percentage. I know that this percentage has a decimal right here, because we kind of treat it like a whole number with a percentage in a way. All right, so 60 decimal, then the percent sign. If I move it 2 signs back to turn it into a decimal, I would get 0.6 once again. Same thing, either way. Same answer regardless. Look at this one, negative 9/10. It's already into a decimal for you. So whenever I turn it into a percentage, all I do is move the decimal twice to the right. 1, 2. Any empty spaces get a 0. Now this is 90%, but don't forget about your negative over here. So negative 90%. Looking right here, this is 350%. Whenever I turn a fraction into a decimal, instead of going 2 spaces to the right because that turns it into a decimal, I'm going to go 2 spaces to the left. 1, 2. So now this decimal is 3.5. And let's go and turn it into a fraction. So it has this whole number out in front. This is going to be a mixed number because it has that whole number out in front. It's going to be 3 and then a fraction with it. So this 5, it's in the tenths place, so I know I want to have a denominator of 10. And then the numerator is just whatever this number is after the decimal. Here it's a 5, 3 and 5/10. Now, if I can simplify, I need to. 5/10, I could divide both the 5 and the 10 by 5. That's the greatest common factor there. And I end up with 3. Notice how the 3 doesn't change. We can't simplify that. And then 3.5. 3 and 1/2. 1, to turn it into a decimal, it's kind of tricky, but remember, every whole number has a decimal right after it. Literally, it'd be 1.0 if you wanted to add the 0, just to show that it is a decimal and you have it included. All right. What if it was 4, the whole number of 4? Well, there's a decimal right here, right afterward. It would be 4.0. All right. To turn 1.0 into a percentage, I'm going to move the decimal 2 places to the right. Any blank spaces get a 0. And now this is 100%. Hey, so that's what 100% looks like. 1.0 as a decimal, and 1, the whole number, as a fraction. Notice I didn't write the denominator of 1 because we just understand that there is 1. We don't have to write it. So that's what 100% would look like in decimal form and in fraction form. We give that an erase. 1 second. Let's go to the next one. Where were we? There we go. So I have 1.7. Whenever I turn a decimal into a fraction, I'm looking to see where the place value is after the decimal. This one goes all the way out to the tenths place. I'm going to have 10 in my denominator. I put whatever number is after the decimal. In this case, it's a 7. That becomes my numerator. And then if there's a number in front of the decimal, like there is in this one, This says 1.7. Notice how it's not 0.7. This 1 is a whole number, and it will join out here, and this will be a mixed number of 1 and 7/10. Let's look at this one. We have the percentage that we're starting with. So, whenever I have a percentage, there's always the decimal right there, right in front of the percentage sign, unless it's shown for you elsewhere. All right? It's not written. That's where I always assume it is. So I'm going to move it 2 spaces to the left this time, because that's how we go backwards, this way. So I get negative 2.25. That's my decimal. So let's look at this. Whatever place value the number extends out to, that's my denominator. This one goes all the way out to the hundredths place. So I'm going to have 100 as my denominator, and then I just put whatever number is after the decimal as my numerator. That's 25 in this case. And then this is a whole number, and it stays right outside, and it becomes a mixed number. So negative 2 and 25 over 100. I can't simplify the negative 2. It stays the same. But 25 over 100, I could divide both of those by 25. Now we get 25 divided by 25 is 1. 100 divided by 25 is 4. Negative 2 and 1/4. That's what I'm looking for. Don't worry about this one right here. That's a different kind of decimal. It goes on forever. It's not a rational number. It was just a mistake on my part. I meant to put a different number as the denominator, and I didn't. So just ignore that one. Don't do it. That is an irrational number. So don't worry about that one. Looking down below, I believe we did it. I think that is the end of the study guide. Yep. The last part is the word search. I just put that in there for fun. Go look through the word search, complete it if you'd like. Something to do. And that is everything. That's the study guide. Please study it and review it. Watch the videos if you need to. They are really helpful. They kind of explain every problem, or at least go through the key that I posted and look through those. We're going to take the test. And if you try all these problems and really try your best, I know you can do well. All right, I will see you guys in class tomorrow.